Today we'll be going over question 3 of the 2021 Methods Exam 1. So firstly, consider the function here, g of x equals 2 sine 2x. State the range of g. This is pretty simple. So this value out here is the amplitude of sine functions, and that just means that basically this sine function does not deviate by a value of 2 from 0. So if we draw it out here, just a basic sine function, it does not deviate from 0 or from the origin by any more than 2 or negative 2. So therefore the range is from negative 2 to 2. And we can write this by saying that y is an element of negative 2 to 2 with square brackets, as it is inclusive, as the y value can be either of these values. Next one is state the period of the function. So the period of sine functions is just 2 pi on, the coefficient of x, which is this value here, which is 2. So we can write p equals 2 pi on 2, which equals pi. This just means that the function repeats every pi, or every 3.1 units, every 3.14159, the value of pi. The last one is solve 2 sine 2x equals root 3 for all real numbers, which is this part here, the domain. Therefore they are expecting our answer to be in the form of a general solution. So we can start off by saying 2 sine 2x equals root 3. We can divide both sides by 2 to get rid of the 2, so sine of 2x equals root 3 on 2. Now I've got a really easy method of memorizing all the exact values. So you start by drawing a circle. Now you can write all the 3 basic angles, like this. You can label them, so pi on 3, pi on 4, and pi on 6. Writing 1, 2, 3, and then downwards, and then 1, 2, 3 back up. So 1, 2, 3, and then 1, 2, 3. Then add denominator of 2 to all of them. And then square root the numerator. Now we know the square root of 1 is just 1, so we can remove these ones here. And these are now your coordinates of all the basic values in quadrant 1, which is this one here. And we know that x is the cos and y is the sine. And that is how you can remember all the basic angles of cos and sine. So now we know that root 3 on 2 is this one right here, which is pi on 3. However, pi on 3 can also occur right here. This angle here can also be pi on 3. So therefore, we do pi, since it is in quadrant 2, which is here, where sine is also positive, we can do pi minus pi on 3, which equals 2 pi on 3. So therefore we know down here 2x equals pi on 3 and 2 pi on 3. Now we can start writing our general solution for this equation. So 2x equals pi on 3 plus 2 pi n. This part here is because in order to get back to this value of pi on 3, we have to go round the circle here by a value of 2 pi to get back to this angle. Or we can go back the other way, and n is where n is negative, and therefore n has to be an element of all integers. So it has to be either 1, 2, 3, 4, or negative 1, 2, 3, or 4, and so on, in order for this to be true. And now we can completely solve the equation for x by dividing everything by 2. So wrong, so that you have to write n is an element of z, and that is the first answer. The second one, where we use 2 pi and 3, 3 plus 2 pi n, sorry, I add commas there, where n is an element of all integers, and we solve for x, so x equals pi on 3 plus 2, divided by 2, so just plus pi n. N is an element, of z. And this will be your second answer, and you will get the full 3 marks for this, and then all your working as well.